Good afternoon, boys and girls. This is lesson 1 of Unit 5. And in this unit, we're going to look at graphing polynomials. We're going to look at graphing them by their roots. We're going to look at finding all different types of solutions in a polynomial function. Today, we're going to start off with simply writing a polynomial in factored form given its roots. So we're going to do a lot of reviewing of what we've done before. So the first thing I want you to know is the degree of the polynomial also tells us the amount of the possible amount. Let me change that. The possible amount of the maximum number of roots. That might not make any sense, but it tells us the maximum number of roots that you could have. Okay? And we can find those roots by graphing. So we're going to start by graphing some function. We're going to look at the degree and tell the possible number of maximum roots, and then we're going to graph it to see exactly how many real roots it has. So if I look at x squared minus 6x minus 7, because it's a second degree equation, the number of maximum roots it could have is 2. Let's graph it to see what the real roots look like. I'm going to use Desmos, and I've already put the functions in so that we can see, and I didn't count on that happening, but I'm going to just make that a little smaller. Okay, so we see that this has 2 solutions. I don't think I put that in correctly, x squared minus 6x minus 7. So it has a solution at -1, and it has a solution at -7, I think, or -1 and +7 are the solutions. But it has 2, so that's what we want to look at. It has 2 solutions there. In this next polynomial, it's a cubic function. The highest degree is 3, so therefore the most roots it could have is 3. So the first one actually had 2. And we're going to graph the second one. It's cubic. The most it can have is 3. Let's see how many it actually has. Okay, it actually has 1. It has 2. Now, there's something going on at this root that we're going to talk about later. You see how it actually doesn't cross the x-axis? It does what I say, bounces back up. We're going to talk about that later in the week. But right now, I want you to see that it has 2 real roots. So that has 2 real roots, although the maximum it could have had was 3. This is another cubic function, x cubed minus 8. You may recognize that as the difference of 2 cubes. So this is the maximum roots that it could have is 3 because it's a cubic function. The degree is 3. Let's see how many real roots it actually has. So if I graph this, I see that it only has 1 real root, and that root is at 2. It has only 1 real root. The scale of this is 2, by the way. So this has only 1. And it didn't have that little thing the other one had where it bounced back up. So we're going to talk about why this only has 1 real root when it could have as many as 3. So this next one, once again, this is quadratic. It's the second degree. So the maximum number of roots would be 2. Because we always look at the highest exponent. That's what we're looking at, the highest exponent. And so let's graph it to see how many real roots it actually has. Oh, look at there. It never crosses the x-axis, so it doesn't have any real roots because it does not cross the x-axis. So the number of real roots this has is 0. This is, again, quadratic, second degree, so the number of maximum roots is 2. And let's graph that to see how many it actually has. You can see that it has only 1, and that one is at -3. Again, I want you to notice there's something different about this one, how it bounces onto the x-axis and then bounces back up. We're going to talk about why it does that, but I just want you to kind of notice it's doing that sometime. And it's changing the number of roots that we have. So that one only has 1 because it only touches the x-axis 1 time. So it only has 1. And finally, again, this is x cubed, so the maximum number of roots would be 3. And let's graph it and see exactly how many it has. And look at there, it has 1, 2, 3 solutions. Okay, just like it's supposed to. That one's behaving nicely. It has 3 solutions, and that's how many we thought it would have. Okay, so let's keep moving on. We want to notice something between these two roots. I don't want to do that. I don't know why I got all the way down there. Okay. So we can also find the roots when the equation is given in factored form. So when this is given in factored form, remember we set each equation equal to 0 and then we solve. To find the degree, we essentially count how many x's we have. So this is x times x, which is going to give us x squared. So this is going to be a second degree polynomial if we were to multiply it out. So because it's second degree, we want to call it a quadratic. And we want to look at its roots. So remember, we found the roots by setting each factor equal to 0. So just as a review, I'm just going to do that above here. So we have x minus 3 equals 0. We add 3 to both sides. We get x equals 3, which is one of the roots. And to get the other one, we would have to do x plus 4 equals 0. Subtract 4 from each side, and we get x is equal to negative 4. So negative 4 is a solution, is a root. Okay? So this is quadratic. It has a total maximum of 3 roots, and it has a maximum of 2 roots, and that's how many we have. Okay, how about this next one? Again, we're going to have x times x times x. So that's going to make it a third degree. And of course, if it's third degree, what we're going to call it is cubic. Did I spell quadratic wrong? I'm a math teacher, people. There we go. All right, it's going to be cubic. And what is going to be its roots? Well, we can see, just doing that quickly, x minus 1 equals 0. That's going to give us 1 and negative 4. But where you may have made a mistake is this one, because you may have just said negative 2. But actually, we have to do 2x plus 2 equals 0. We subtract 2 from both sides. We get 2x is equal to negative 2. Therefore, x is equal to negative 1. So we have to take that into consideration, and our other root would be at negative 1. Okay, so this one has a second degree polynomial. It's a second degree. So what do we call second degree? We're going to call that quadratic. But notice it should have as many as 2 solutions, but it only has 1, and that one that it has would be at 1. Now I want you to notice how this root has a square next to it. That's going to become important in the coming days. And because of this square, this is what's making it just touch the x-axis without going through, that little square there. Okay? So the last one I have is third degree because I have x times x times x, so I have third degree. So therefore it's a cubic. And my roots are, be careful with that first root because we have to set that equal to 0. So we're going to get negative 1/3, 4, and negative 6. Okay? How did I get that negative 1/3, you may be asking? It's magic. All right, so how I got the negative 1/3, can I close this? Where's the little thingy, my Bobby? Right there. All righty. How I got the negative 1/3, so remember I have to set this entire thing equal to 0, so 3x plus 1 equals 0. Then I have to solve that two-step equation. So I get 3x is equal to negative 1 divided by 3. Voila, x is equal to negative 1/3. Okay, so what I want you to notice from this little chart is that the roots are the opposite of the factor. So in other words, notice when I have a root of negative 4, the factor turns out to be x plus 4. When I have a root of 3, the factor turns out to be x minus 3. So here is a rule. I'm going to delete that. Here's a rule, and it says this. If K1, K2, and K3 are roots, then we can write it in factored form. We can write this polynomial in factored form by saying x minus each root. So x minus root 1, x minus root 2, x minus root 3, so on and so forth. We can write that polynomial that way. So let's try that. Let's try doing a couple. Okay, since I am no longer using decimals, I'm going to go ahead and make my screen big. Okay, so I've given you some roots. I told you the roots were -3, -1, and 2. So what we want to do with that is we want to write this as x minus -3, and then x minus -1, and then x minus 2. Now, would we ever write that like that? Of course not. That looks weird. X minus 2. When we have that double negatives in there, we just write that as a plus sign. So this is going to be, and I should actually write y is equal to here. So let me just go ahead and change that to say y is equal to. So I can write this as y is equal to parenthesis x plus 3, because I'm doing the opposite, x plus 1, and then x minus 2. Okay? And that's a little small, so I'm just going to make that a little bit bigger, maybe. Just so you can see it better. Too big? Okay. All righty. So let's do the next one. I'm not going to write it the long way first. I'm just going to show you the answer. So this would be y is equal to, and then we would have parenthesis, x minus 5, parenthesis, x minus 4, and then that last one would be x plus 5. I'm sorry, x plus 1. And that's our equation written in factored form. Okay? Now this one says, what is this little symbol? This means plus or minus. So that means that we have two factors. One is plus 5 and the other one is -5. So we would write y is equal to, the first factor, minus 5 would be x plus 5. The second factor, -5, would be, the positive factor would be x minus 5. In this one, we have zeros we have a 0 as a factor, so we could write this x minus 0 and then x plus 5. But we would never write x minus 0. That, again, looks weird. So we can just write it as x and then have x minus 5. Okay? Now, that's if I'm given the roots. What if I am given a graph? If I'm given the graph, then I have to find the roots. So remember, the roots are where it crosses the x-axis. So I want to look here and here. That's 2. I think this is 1 and -1. Well, -1 and 1. So then my roots are -1 and 1. So my equation is y equals x minus, well, let me just be consistent, x plus 1, x minus 1. Okay? On the next one, again, I'm just finding my roots. My roots are, well, that's a little bitty. Let's see if I can't figure that out. I hope it's bigger for you. Let's see, that looks like -3, 0, and 4. So my roots are at -3, 0, and 4. So then I'm going to write it as y is equal to x plus 3, x minus 0, which remember we don't ever do that, and then x minus 4. So simplifying that, I'm just going to bring the x out in front, and we have x plus 3, x minus 4. Okay, let's see. I think we only have 2 more to do. So this one has only one root, and that is at -5. Okay, so how do I deal with that? I can write y is equal to x minus 5. But I know from experience that that's a linear function, and this is not a linear function. So once again, remember, see how it's just bouncing on there and then bouncing back up? So anytime I see that, I know I have what's called even multiplicity. And because this looks like a parabola, I know that this should be a quadratic function. So I'm just going to go ahead and make it x minus 5 squared. And again, we're going to talk about that multiplicity in a couple of days. All right, and the last one has 4 solutions, and those solutions are -5, if I'm correct. My eyes are not deceiving me. Negative, so that's 0, -2, -3, and then -1 and 1. Okay, so then my equation is going to be y is equal to x plus 5. Remember, we do the opposite when we write it in factor form. X plus 3, x plus 1, and finally x minus 1. Okie dokie, boys and girls. All right, I hope you've enjoyed this video, and I hope it was helpful. I will see you guys tomorrow.